Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet. Doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, at the world's largest coal export terminal, leading tradesperson Darren Westwood has a massive 23-tonne gearbox in full swing.
Those coupling bolts have been in service now for 18 years.
And it's a bolt to the finish to get this mighty bucket wheel spinning.
Worst case scenario, one bolt, one shift.
When a 550-tonne excavator calls in sick, maintenance supervisor Kenny Diamond and his team of experts must diagnose the problem.
It's quite urgent we get the job done, as it's leaking oil and we don't want to run it dry.
But a call to duty means there's no day off for this heavy lifter.
This has to go back in today and the machine has to be working at 6 o'clock tonight.
Elsewhere, a very different piece of mining equipment, an underground roof support, needs a lift. But there's a major hitch for mechanical fitter Sean Gunning. The lifting point is missing.
So we're just trying to decipher how we're going to lift this.
What would have been a simple lift just got a lot more challenging.
Trying to find another point where we can lift it up.
And there's no time for gushing at Wivenhoe Dam. Maintenance on the radial gates requires a skilled team led by a highly experienced dam operator.
Just closing the gate to make sure no one else falls. I'm just going to climb down the ladder.
It's all about pressure. A high-pressure water gun, that is. The world's largest coal export facility is at Port Waratah Coal Services in Newcastle, New South Wales. Every year, Port Waratah's terminals have the capacity to export 145 million tonnes of coal. The coal is transported by train from mines across the Hunter Valley region and loaded onto 1,200 vessels and shipped out to the world. This giant bucket wheel is critical in meeting export deadlines. Known as a reclaimer, it's capable of scooping up 9,300 tonnes of coal every hour. Running 24/7, 365 days a year, reclaimer number 411 has stopped turning for some major maintenance.
Today's task is to remove 411 bucket wheel gearbox. So he's driving the bucket wheel which picks up the coal and delivers it to the conveyor.
Having worked on building these machines himself, Darren Westwood, known around here as Booker, short for the Book of Knowledge, knows the importance of keeping this mega machinery in check and fully operational. Ahead of him is a huge job. Weighing in at 23 tonnes, the massive gearbox driving reclaimer number 411's 30-tonne bucket wheel requires replacing after almost 2 decades of operation. A new gearbox is transported 4,000 kilometres across the country to arrive at the Kooragang coal terminal for the replacement. The gearbox is attached to the bucket wheel drive shaft by 16 large bolts. Taking them out sounds like an easy task, except for one challenging technical issue.
Those coupling bolts have been in service now for 18 years, and past experience has showed us when they're jammed, they take about 130 tonnes of removal. One bolt, one shift. So 16 days of just bolt removal before we could actually remove the gearbox.
Bolt removal is an extremely difficult task which will require a crew of 4 men working 12-hour shifts continuously around the clock. How long it will actually take to remove the gearbox is unknown, but being such a critical piece of machinery means deadlines are tight. So the less time this monster's in shutdown, the better.
We've been on this planning process for about 4 weeks. So correlating all the gear, getting the gear together, getting it tested, making sure it works, and then packing it up and delivering it to site.
Booker is the master of gearbox removals. He's already been involved in 2 of these heavyweight gearbox replacements on the other reclaimers on site. From previous experience, he knows there will be challenges. Once inserted into the gearbox, these indestructible bolts were never planned for removal. And after nearly 20 years in service, his worst nightmare is they won't come out at all. But the master has a backup for that scenario. Booker's plan B is in the form of 4th-year mechanical fitter apprentice Will Hammond.
From past experiences on other jobs, stud extraction being one of the most critical paths in order to get the gearbox off.
For his final year assessment project, Will designed this bolt removal tool, which has been cleverly called the Nutcracker. Yet to be tested on the job, the device will only be trialled if a bolt becomes stuck in the gearbox coupling.
It's got a 150-tonne hydraulic cylinder mounted inside it, and the idea of that is it supports the remaining studs out.
With Will's hydraulic jack on standby and a new gearbox ready to go, Booker only hopes an agonising history with these bolts doesn't repeat itself. 750 kilometres north, across the Queensland border, near the regional township of Oakey, there's a massive machine flexing its hydraulic muscles at the New Ackland open cut coal mine. This 550-tonne excavator and its monstrous 30 cubic metre bucket should be working in the pit, chewing its way through rock and soil to get to the coal below. While it might look like it's fighting fit, the team are actually trying to get to the bottom of a serious mechanical issue. This morning, the only thing this excavator is doing is creating a massive challenge for the mine's maintenance supervisor, Kenny Diamond, diagnosing a problem in one of the 4 slew transmissions.
It's quite urgent we get the job done, as it's leaking oil and we don't want to run it dry, as it'll seize all the gears in the slew trans.
The job is to remove the slew transmission, also called a slew gearbox, and check the massive part for leaking hydraulic oil. A slew transmission is driven by hydraulic motors off the twin engines on the machine. When the operator moves the controls to slew or turn the body of the machine, the slew transmissions rotate to turn the excavator arm and bucket in a 360-degree swing. The pressure is on. The crew have only one 12-hour shift to have this mining machine back on track. To get the ball rolling, some forensics are happening in the belly of the beast, where oil samples are taken to try and determine exactly what type of oil or oils are leaking from where. Preparing the problematic slew gearbox for removal is Mark Van Dongen, a mechanical fitter with 20 years experience.
We're going to pick this motor up off the top of the transmission here. We're going to take it away with a Franna crane. Then we'll get that out of the way on the ground. We'll come back in, we'll undo all of our transmission bolts that hold the transmission in the frame. Then we'll hoist the transmission out.
But none of the big boys' toys will get fired up for these lifts until some smaller tools clear a pathway through these boom arch hoses to allow overhead access for the crane.
The boys are just going to spread the hydraulic hoses there, just use some come-alongs so we can spread them apart.
A come-along is a hand-operated winch used to separate the arched hydraulic hoses. While further down in the excavator, the hydraulic motor is ready to take flight on the boom of a crane. Despite the time pressure, safety is always on everyone's mind.
I don't want to get hurt. I want to go home to my family at the end of the shift. If there's pressure, it comes with the years on the job, but you've still got to make sure that you come out the other end of the job with all your digits and everything in place.
With the motor airborne and out of the way, the team's getting closer to their prime objective, the leaking gearbox. The sooner they can get to that, the better.
If we don't repair this leak and seal, the slew motor will actually run out of oil and seize up, and that'll be the end of the machine.
And that's not Kenny's only concern.
If the digger's not operational by 6 o'clock tonight, they're going to be behind on their overburden.
Having one less excavator working the pit, even for just one shift, means lower production, lower profits, and a pile of overburden that's got to be moved. Getting this done in such a short time frame is a major challenge, considering there's going to be a lot of mechanical detective work to figure out the cause of the leak. Stepping into the unknown, will this machine be ready for a call of duty on the night shift? 940 kilometres north of Oakey is the tropical city of Mackay, a region famous for sugar and mining. The Hastings Deering Asset Solutions Workshop has been charged with overhauling a hydraulic roof support from a longwall underground coal mine in central Queensland. For Sean Gunning, mechanical fitter acting as project lead this morning, the shift is off to an interesting start.
Well, last night, boilermakers have made a mistake, obviously, and cut the main lifting point off.
The crew need to raise this hulk to access a cylinder leg, but there's a problem.
There's supposed to be a lug exactly like that on this side, but in your main weld areas around here, they've obviously found cracking, and hence why they had to cut it off.
The boilermakers on the night shift have cut off the main lifting point.
I don't think the boilermakers would have known that we had to lift it.
Ironically, lifting is what these roof supports are all about, powered down in a workshop. It's hard to take in context these transformer-like components. But hundreds of metres below the surface, this roof support is an integral part of an underground longwall mine. Projects and Overhaul Supervisor Warren Samuel, known around here as Wazza, sees hundreds of these units come through the workshop.
This is just one component out of a complete longwall package. This roof support is about 65 tonne.
Longwall mining is an underground coal mining technique using hydraulic-powered roof supports which are interconnected along the length of the longwall face. Massive shearers cut coal from a wall face, which falls onto a conveyor belt for removal. As the shearer advances along the wall, it exposes an area of the coal seam overhead that's retained by the roof support to maintain a safe working environment.
So these hydraulic roof supports support that by putting anywhere between 1,400 to 2,000 tonnes of pressure back into the roof to be able to hold that strata in position.
To put that in context, each of these roof supports is capable of holding the weight of 4 A330 aircraft. But before this unit can start to support that vast amount of weight, some problem solving needs to happen. With 5 years experience on the job, Sean's using a solid alternative.
We've got some other lifting points just in there. We're just gonna throw some bigger shackles through, and we'll just have to change the lengths of the chain that we've shortened. And hopefully it should be all good. So we're just going to put this other shackle on, and then we'll have to move the crane back over that way and lower the chains down.
But jostling bulky machinery is never simple. Time to call in the big guns. Cue the overhead cranes.
A little bit too much for one single crane to do, just because when you go high it sort of picks up a little bit more than 60 tonne, the alarms will start going off because they're only 60 tonne cranes. So here's 2.
With 2 cranes in use, Sean uses a 100-tonne spreader beam to balance the weight. Heavy chains are readied to carry the 65-tonne load.
Because we've had to change the lifting points where we're lifting, we've just got to change the amount of links, how the crane's set up, just to get it to lift evenly.
It's a time-consuming process, adjusting then readjusting chains to get the balance right.
Very heavy. Finger biters, sure. Lots of pinch points.
An hour into the job, and another challenge presents itself for the crew to detangle.
The side seal has been taken off, so the pins that are sticking out, there's little grooves above them that the chain's getting caught in as we're going up, so it's getting tight above the pin, but it's still loose down the bottom from the lifting point, and we needed to get tight.
With delays beyond their control, will the team find a solution to lift a roof support stuck firmly on the ground? 80 kilometres northwest of Brisbane, sitting steadfast on the stunning landscape of the Brisbane River, is the impressive Wivenhoe Dam. This earth and rock structure is 59 metres high and 2,300 metres long. The dam wall holds back the 1.16 million megalitre reservoir when at full capacity. The concrete spillway at Wivenhoe Dam has 5 radial gates, 12 metres wide and 16 metres high. They're among the largest of their type in the world. Each year, the radial gates undergo a crucial safety check of the hydraulic motors and winches, along with raising the gates for a visual inspection. Doug is a veteran dam operator and leading today's radial gate inspection. Having worked here for 22 years, he knows the dam well. During that time, he's witnessed extreme weather events which have relied on his skill as a dam operator.
Done many releases, but when we had a really big rain event.
The decision to build the dam came after the torrential rain from tropical cyclone Wanda flooded the Brisbane River, devastating the city of Brisbane and surrounding areas in January 1974. Today, Doug and his team, Matt operating the crane and apprentice Ash, are preparing to retrieve a 63-tonne bulkhead gate stored in a large underground concrete container. Radial gates are the most common type of spillway gate in use today. Water pressure is transferred from the curved face to the radial gate arms, which transfer the load to bearings on either side of the gate opening. A bulkhead gate is inserted vertically in the spillway to hold back the water, allowing the radial gates to open for maintenance. Matt is in charge of driving the enormous crane which straddles the dam wall. Using a remote control, he's able to position himself to monitor operation. The main purpose of the crane is to retrieve the bulkhead gate. It's a slow process moving the crane along the wall.
Well, the biggest challenge for Matt is, of course, lining him up and getting him to go inside the slot. Pretty restricted, the area for to go in.
The procedure relies on Matt's skill and experience to drop the locking hooks into the bulkhead. Slowly raising the bulkhead clear of the concrete container, the enormous size of the gate is revealed. Moving along the dam wall, tracks guide the crane into position. The bulkhead gate is designed to hold back the lake, so it's expertly engineered for weight reduction.
When you look at the gate, it's fatter at the bottom. That's because there's more head pressure at the bottom, so it exerts more pressure. So as it's going up the gate, you'll see it's getting narrower and narrower.
During the maintenance period, a radial gate is inspected each day until all 5 are done. Today, it's Bay 2. The bulkhead is lined up with the bay using marking indicators to assist Matt to centre the position of the bulkhead in the spillway. Slowly, the bulkhead is lowered into the lake. Matt is constantly watching and adjusting the crane. Fine-tuning guides the bulkhead gate smoothly into the slots.
These little shiny ones here, they're the end rollers. They'll help if going down, so if it's not quite laying straight, the rollers will help it shimmy its way down. Ideally, they won't touch. These other big fellas, they actually take the loads.
With the bulkhead lowered safely into position upstream, water cannot enter through the spillway. The dam serves a dual purpose of water supply and flood mitigation. Operations and dam safety engineer Michael Raymond supports the team that operate the dam during flood events.
The dam won't stop all floods, but it will actually certainly reduce a lot of flooding, and what it does that by slowing the floods down as it travels through the dam.
It's during extreme weather events when the ongoing maintenance operations performed by Doug and his team pay off, ensuring the radial gates holding back the lake are functional at all times. It's been a busy morning, but with a slow-moving crane and 64-tonne bulkhead finally at the bottom of the lake, there's a sinking feeling this job's slipping behind schedule. At Port Waratah, leading tradesperson Darren Booker Westwood and his crew are gearing up for Reclaimer 411's gearbox removal. First up, they need to extract 16 large coupling bolts from the gearbox drive shaft, and with past experience of 1 bolt, 1 shift, Booker's hoping history won't repeat itself.
The reason the crew behind us are so big because you've got to use packers and jacks and pressures, and there's a lot of communication with regards to pressure on, pressure off, release, just to remove the bolts.
Bolt removal is a high-risk operation. Working with hydraulic pressure in a confined space environment and at height, these highly skilled mechanical fitters are harnessed onto the work platform. Risk assessments are in place and an emergency rescue plan is on standby. Safety is the name of the game for these guys.
Give it to it.
Working shoulder to shoulder, with all eyes on the bolt, it's a four-man job. The jack operator gives a verbal cue for the pump to start.
Righto, mate, give it to it.
So that's a bolt that's been removed, and it's one of the first ones, and that's why you need so much force. Every time you do 16mm straight on the jack, then's got to be replaced with a packer, another 16mm, and we've got to do that over 110mm. The whole bolt length's 300mm, so it takes a bit.
Gauging the amount of hydraulic pressure needed to remove the bolts is an indication of whether this job will be delivered on target.
Righto, mate, give it to it.
The crew are using a jack to move this bolt with a high-pressure hydraulic pump with the equivalent force of 50,000 pounds per square inch, or PSI.
Righto, nice and steady.
And it's not moving.
Suck him in.
Time to wind it up a notch to 60,000 PSI.
Righto, Shippy. Nice and steady.
Finally, movement. And the bolt comes free. After almost 24 hours of continuous labour, just 8 of the 16 bolts are removed from the gearbox. The only way to access the remaining coupling bolts is to manually rotate the 30-tonne bucket wheel. It's a dangerous task, and everyone except for the winch crew are cleared from the job site. Communication between the crew is critical, as winches and chains are locked onto the buckets. Turning this Titan is a slow task. Finally revealing the remaining 8 coupling bolts. With the bucket wheel rotated and safely locked, Booker's bolt crew are keen to get back on the tools to get the old gearbox out.
Nice and steady. Righto, mate, give it to it. Righto, give it to it.
With patience, determination and focus, these masters at work have cracked the code to remove the bolts. But Booker's been here before, so he's not ready to acknowledge victory.
Don't count your chickens before they hatch, of course we've still got 6 to go.
The crew are so close. They're determined to complete the job on their shift so they can have bragging rights. It's 15 bolts down and 1 to go. Across 3 shifts, Booker's crew removed 16 bolts in 32 hours, a record time. Plans now move to installation of the new gearbox. But a changing weather forecast could mean their biggest dilemma is yet to come. Out on Queensland's Darling Downs, a 550-tonne digger has been taken out of the pit at the New Ackland coal mine to get to the bottom of a mysterious leak in a slew transmission. An issue maintenance supervisor Kenny Diamond and his team need to solve before the night shift.
It's quite urgent we get the job done as it's leaking oil, and if it runs dry on oil, the gears will seize up and the machine won't be able to swing at all, so it'll be up for a new slew trans.
That's a costly venture that the guys are working hard to avoid.
As soon as we get that slew trans out, we'll know whether it's worse than just the seal.
With the 200-kilogram swing motor out of the way, the slew transmission is next in line for a morning flight on the crane. This hefty passenger weighs in at 2 tonnes. Mechanical fitter Mark Van Dongen stands by to guide it through the forest of hydraulic hoses that control the boom arm and bucket.
Trying to pull this out. Hopefully we find that the seal's damaged or not installed correctly, and we can rectify the problems.
Mark's keen to get the massive part on the ground and try to work out where the leak is coming from. He's hopeful, but there's a lot of unknowns. The crane makes light work of this solid piece of machinery, cautiously easing it down onto a pallet. After 2.5 hours of hard slog, the real dirty work can begin. With the grease cleared out, a rattle gun is used to remove the bolts and reveal the inner workings of this slippery character. Yet again, the crane's called into service. As the team probe the innards of the slew transmission for answers, the clock ticks closer and closer to the shift change. In tropical Mackay, the mercury is well past the 30 degrees Celsius mark in the Asset Solutions workshop. Overhauling this piece of mining equipment is proving almost as challenging as the job this hydraulic roof support undertakes hundreds of metres below the surface.
It's essentially an evolution of a block of timber that people used to use in coal mines. The hydraulic roof support has evolved into what we see now. Our nickname for that is a chock.
It's the perfect analogy for these massive mechanical wedges which sit between the floor of the coal seam and the roof of the longwall mine. Today's mission, supervised by Wazza Samuels, is to raise the unit to access a faulty hydraulic leg.
Through testing, we found that one of the leg cylinders, which holds the top of the roof support up, has got a leak in it, so we're replacing that out at the moment.
It sounds pretty standard, but not when the machinery weighs 65 tonnes and not when one of the main lifting points has been removed. Sean Gunning, the fitter on project lead this morning, has been working with Wazza and the crew to wrangle this metallic behemoth into position.
So it needs to be moved forward, it needs to be a stand under the bottom. So we just had to come up with another idea how to do it.
After 5 years on the job, Sean isn't phased.
Fair few jobs come through where you have about 50 to 60 of them, all in a really short turnaround.
But with this particular unit, nothing is happening quickly.
Generally what we will do is we'd do it a lot different to this. We'd have the crane set up holding the canopy up. We'd take the leg out and there'd be a new one to go straight back in. But we don't have any cylinders on hand at the moment, so this one's going to get taken out, which is why we have to put the stand under it.
Progress is slow, but safety is always the top priority. And throughout the operation, Wazza is standing by, ready to give expert advice and hands-on assistance.
No, well, I came from the same place that these guys are now. I don't see why there's any reason why I can't give back if they need a hand. Yeah. I'm just concerned that we're going to put a lot of weight on this once we go to lift it all in one hit. So if we put it back down again, hook the hydraulics up to the front leg cylinders and just take it up so we can remove that.
I think we will be if we were just to take the stand out and work it for you.
Yeah. What do you reckon, Sean?
After 2.5 hours, with stands and chocks in place, will Sean and his team be ready for liftoff? At Wivenhoe Dam, Doug and his crew have just settled the enormous bulkhead gate into place in the spillway to hold back the lake. Before they can open the radial gates, Doug has to remove the crane's connecting hooks from the bulkhead gate.
Just closing the gate to make sure no one else falls. I'm just going to climb down the ladder, go down so we can disconnect the crane.
It's a risky trip down to water level and requires Doug to wear a harness to reduce the dangers of a fall from this height.
Come and do the other one. All clear, Matt. Up we go.
The radial gates have not opened to release water from Lake Wivenhoe since 2011. But when these massive gates open onto the spillway, it's an awesome spectacle. With the bulkhead gate sealing Bay 2, Doug prepares to take vital readings from the hydraulic winch motors, which raise the radial gate.
It's full operational swing. I'll give you a call every metre so you can obtain your readings. Ready when you are, you can start the pump.
As the gate begins to rise, water trapped between the bulkhead floods onto the spillway. It's enough water to fill a family-sized swimming pool. Paying careful attention, Doug checks the pressure gauges.
Every metre we just get our pressure readings. And the different size you can see on the gauges here. We've got the different pressure gauges, raised, lower and case pressures. So we just record those at every metre interval.
While Doug is doing his checks, he's coordinating with Matt, who's taking readings on gate positioning and pump pressures in the winch room.
Matt, 2 metres, 2 metres. We just have a good look around to make sure the brakes are coming off. These are the brake cylinders here. We've got a pressure relief valve here. We just monitor to make sure it's behaving like it's supposed to.
Doug checks the hydraulics for leaks and keeps an eye on the witness mark and bolt to ensure they're still lined up.
Matt, 8 metres, 8 metres.
With the stopwatch on hand, a record is made of how long the gate takes to fully open.
Just over half an hour.
It's important to check the gate safety mechanism.
Upper limits come on. That's what stopped the gate coming up. And we also check the hydraulic upper limit. There's an emergency upper limit that'll trip if this one doesn't work. Okay, Matt, if you want to shut that down, we'll just have a look at the, see what she looks like while it's up here.
That means this gate is going to get the full once over. It's all about high pressure. A high pressure gun, that is. Back at Port Waratah, preparations are underway to remove the gearbox from the boom arm on bucket wheel 411. A 130-tonne crane has been brought on site to lift the 23-tonne gearbox. It's a difficult lift. The weight of the gearbox means the boom arm of the crane will be at full capacity. Chains are attached to linking points on the gearbox, but because of its odd shape and position, each chain link must be meticulously fed out, one by one, to make sure the weight is evenly distributed and level on rising. After hours of preparation, the crane rigger gives the all clear to lift the gearbox. As chains take up the load, slowly the massive gearbox rises upward. Hanging from the outstretched boom, the gearbox is carefully manoeuvred into a shipping cradle beside its replacement. An operation that started 6 hours ago, rigging and lifting the mighty 23-tonne gearbox, is finally complete. But that's only half the job. The team is eager to lift the new gearbox early in the morning. But will a changing weather forecast wreak havoc on Booker's best-laid plans? At the New Ackland coal mine near Oakey in regional Queensland, a brains trust of mechanical experts are using their combined knowledge to try and nut out what's causing a leak in the slew transmission from this 550-tonne excavator.
We've only got a 12-hour shift to get the job done. The pressure's on to get it out as quick as we can in the next few hours, ascertain what the problem is, and then we'll make a decision from there and try and get the machine back on tower for the guys at 6 p.m. tonight.
Time is a constant pressure, and this machine needs to be up and running for the night shift. But the question still remains unanswered. What is causing the leak?
So we replaced these about 1,000 hours ago, and usually we get 24,000 hours, and the ones we've replaced are now losing oil.
More and more parts are removed and checked as the team dig deeper, working to solve this increasingly baffling puzzle. But until the oil samples come back from the laboratory, nothing is definitive.
We pulled this slew box out and we've disassembled it, inspecting everything thoroughly as we went. We can't find any evidence of anything being assembled wrong or anything out of place, so unfortunately it looks like it's okay.
It's an unusual situation where a positive is more of a negative.
I'm fairly disappointed that we didn't find anything. Yeah, I would have loved to have seen something damaged. Would have been, if it was an obvious fix, would have been a lot better, yeah.
A huge effort with no real result, and time is not their friend today.
We're at the point now where we can't continue looking at it. We need to start putting it back together so we'll have it ready for night shift. Carefully
and precisely, the team reassembled this enormous workhorse in just a few hours. It's been a challenging shift all round, and even for this skilled team, it's a huge task ahead.
It'll be a fair effort by everybody here this afternoon, but I'm confident that we'll achieve our goal and get the thing going.
Although the team couldn't find an immediate fix, the excavator was back in service for night shift under close supervision. Several days later, oil tests assisted the mechanics to find the cause of the leak, replacing a pressure valve and solving the mystery. Mechanical workshops are challenging environments at the best of times. One crew in the workshop have been battling with this monster, an underground roof support for a large chunk of the morning. After 2.5 hours of trial and error to get this piece of coal mining machinery safely supported and chained up for a double overhead crane lift, it's crunch time.
It was something this big. 65 tonne is not something that you really want to take shortcuts on. We probably go to the nth degree when we're working on the big gear, but it's the same philosophy that we want to take into the smaller gear we work on as well.
Finally, the chains take up the slack, and there's air between the shed floor and this bulky machine. A slight movement in the chains and the roof support jumps. But the experienced team are not phased. There's a support stand in place for this exact reason. It's a painstakingly slow process, gradually moving the machine up and then forward. Amazing to see this massive piece of machinery seemingly defy gravity. But not for long.
Nice one. Okay, so we'll take chains off. Reposition the barricade.
With the roof support secured and in a safe work area, the real work can start for Sean and the maintenance crew, removing a faulty leg cylinder.
You can get coal, you can get anything in there, and the tiniest little speck of dirt can get inside and wreck the whole seal, which will cause it to bypass it. It won't hold any weight, so the roof support will just start lowering. If that happens, it can just collapse, and if you've got workers under there, it's not a real safe thing.
The guys that work down there do audits across the system, so they pick that up pretty quickly and change it out underground, pretty quick smart. So while it's in here in the workshop, we'll take advantage of the fact that we can do it in a workshop environment with an overhead crane.
3.5 hours after the discovery of the removed lifting lug, Sean attaches hydraulic lines to raise the roof support. It's been a massive effort to get to this stage. And finally, the guys get a good look at the rear cylinder. But just like the Mackay Heat, the work's relentless. Their next mission, to remove this 3-ton leg. Every year at Wivenhoe Dam, the 5 radial gates are inspected and cleaned. Today the team have been assigned maintenance of gate number 2. Matt doesn't mind working under pressure to remove the thick algae. Checking the radial gate with apprentice Ash, Doug examines the submerged surface from an inspection platform inside Bay 2.
We got no dramas. Not that we found yet anyway. And that's pretty typical.
To protect the metal surface from rust corrosion, the submerged section of gate is painted with a hard-wearing epoxy paint. Previous spot damage is also examined to ensure the integrity of the repair.
This is the patch that we did previously. Now this is a 2-coat epoxy system, high-build epoxy. The first coat's a little bit smaller, and the next one's a little bit bigger, so it overcoats. So the next one would come a bit bigger like this.
After many years on the job, Doug compares the condition of the gate from his previous inspection. Satisfied it's in good condition, he gives the go-ahead to lower the gate.
All right, here we go.
Checking the winches, Doug has a stopwatch on the lowering gate. It's important to know how long it will take to close completely.
23, 35, and 30 going up. Got a bit of 104 tonne assisting it going down.
With the inspection and cleaning complete and the gate secured, the job is done. With a structure as important as Wivenhoe Dam, inspections are crucial and equipment failure just cannot happen.
It's a rewarding job. We maintain the gear and watch it operate.
The ongoing maintenance provided by Doug and his team ensures the radial gates at Wivenhoe Dam will be fully functional at all times. In Mackay, a team of fitters are slowly making progress fixing a leg cylinder as part of an entire overhaul of underground mining roof supports. A big part of this job is problem solving, something fitter Sean Gunning and his crew have put to the test multiple times today with the challenges of lifting this 65-ton giant. It takes teamwork and combined skills to work through these problems.
We've got a lot of great boys and a lot of experience here. As soon as I started, I could just see how well everyone was gelled together, and it's just one big unit basically. Everyone seems to be mates outside of work as well.
After a day of stops and starts, finally the supports are in place and the team can get down to the job they had planned today. A chain block is used to support the 3-ton leg to ease it out.
The time that it takes to do that preparations mean that we can do the job in a safe manner. The most important thing is get home at the end of the day. Spend time with your family and do the things that you enjoy doing.
5.5 hours have ticked by. And success, finally. The leg cylinder is free. Sean's a happy man.
Glad it's over. You get that on big jobs, but you gotta take what you get and roll with the punches, as they say.
Now that the guys have got the cylinder out, we're going to send that away to our overhaul facility. It'll be pulled apart, put back together again, so they can go back into another roof support. This roof support itself has got another leg cylinder that's ready to go back into it. So tonight, night shift will throw that in, we'll put it back up and begin the rehosing of the roof support.
After several false starts and lengthy delays, the team have pulled together to get the job done. When the rear leg is replaced, this roof support will go back into service at a central Queensland underground coal mine. At Port Waratah, Booker is at the mercy of the weather. His plans to lift Reclaimer 411's new gearbox grind to a halt.
The rain has come in. The forecast is scheduled for about 40 millimetres of rain. So that's come in and impacted the schedule.
The work site is a total washout.
The main priority when it rains is that we can't allow people up on steelwork, the slipperiness. It's utmost important that safety is our first priority.
Water, man and machine is a lethal combination, making a 23-ton gearbox lift highly hazardous. And this downpour has dampened any hope of activity on site. Ongoing delays to the maintenance schedule will have a serious impact on operations.
We've got to reschedule shifts and reschedule coal piles and a whole host of things happens.
As the window of opportunity to stay on time and on track slowly closes, Booker needs to look for other options.
The lift that we're going to do today will be cancelled if any sign of high winds because they've got to have control. So it might end up being the night shift will be the best place to do this work today.
Any type of critical lift after dark presents a whole new set of challenges. But right now, the rain is unrelenting. And it's Booker's job to assess the risks and make the call.
Due to the weather conditions, we're going to cancel today's crew and restart the night shift tonight.
As the day shift mechanics head home, it's a huge blow to operations. Right now, the installation of Reclaimer 411's new gearbox is officially off limits. Losing a 12-hour work shift means the night crew clock on for one hell of a battle to get 411 back on track. Mechanical fitter Mark Doll is called in to lead the charge, and there's only one thing on his mind.
100% about safety, making sure everything's all right and ready to go.
Preparing for a moment of reprieve. When it comes, it'll be all hands on deck.
So the torrential rain stopped. It's still a bit windy and we've got scattered showers, and when the opportunity comes, they're setting the lift up now. They've got it slung on the crane. They're going to swing it in.
Mark gets his moment. The rain is predicted to ease off, and he gives the team approval to go.
Heaps of eyes on the job, just seeing where the clearances and that are.
Make no mistake, wet surfaces, night lighting, shadows, and the smallest change in weather conditions, and this lift could quickly become disastrous. From lift up to swing in and descend, the crew's looking to get this done while the rain holds.
The way that the load's rigged up is very important so that we're not having to put it back down on the ground and re-rig it again. So the rigging has to be absolutely spot on.
A 23-ton critical lift is a white-knuckle ride. If the new coupling bolts are to withstand a lifetime in the field, realignment is one of the most critical aspects of this entire operation.
We can roll the gearbox, rotate it manually just by spinning the disc. The bolts have only got 0.1 of a millimetre clearance on them. 120 space of that side.
And it's in.
The gearbox is in position. They've torqued up 4 bolts to retain the weight of the gearbox. It's sitting on the pedestal at the back. The crane's removed.
All that's left are the new bolts. And just to finish off a mechanical fitter's dream, the clearance fit design glides them in with ease.
We'll put 16 on and these blokes will have the bolts torqued up by the morning.
8 hours later, Mark and his team of mega mechanics have done it. It's a spectacularly successful handover to Booker the next day.
The job is now complete, that's why it's nice and quiet. It's finally installed. Just checking the Denso tape on the bolts for corrosion protection.
And to keep the gears lubricated, it's time to fill up the oil.
When it comes to site, it's dry, so we fill them up to the mark. About 680 litres these gearboxes hold.
Will's plan B, the Nutcracker, is shelved for another day. But the hands-on knowledge gained by this final year apprentice is more than enough reward.
Yeah, I've been on the job since the very beginning in the planning stage and seen it progress all the way through to the commissioning, which is quite a rare opportunity, but it's been a really good learning experience for me.
As for Booker, the job's not over until this machine is fully operational. With the gearbox job complete, a full test run is on hold until other maintenance work on the reclaimer is finished.
From our point of view, we just wait the completion of the cable reel work and we can move on. It looks like it's a pretty good job.
Keen to power up this mechanical beast, Booker's on the home stretch. And when Reclaimer 411 is fully geared up, it will be ready to churn through mountains of coal for years to come.